Okay, let's talk about numbers in standard form. Okay, with the standard form or scientific notation, we can rewrite numbers in the form of a times 10 to the n, where n is an integer and a is any number between 1 and 10. Okay, this is often known as the coefficient. This is often known as the mantissa. And as I say, with this way of writing a number is known as scientific notation or standard form. So the number 5,000 in standard form is the same as 5. It's 5,005 times 1,000, or 5 times 10 to the 3. 64,000 is the same as 6.4 times 10,000, which is 6.4 by 10 to the 4. 380,000 is the same as 3.8 by 10 to the 5. Okay, so what have we done there? We have 380,000, and we've written that as 1, 2, 3, 4, 5, 3.8 by 10 to the 5. Okay, so we've moved the decimal point 5 places to the left, so we multiply by 10 to the 5. Okay. What about if we have 0.037? Let's talk about numbers less than 1. Okay, so this is less than 1. So 0.037 is the same as 3.7 by 10 to the minus 2. Okay, and which is the same as 37 divided by 100. 0.0045 is the same as 4.5 by 10 to the minus 3, or 45 divided by 1,000. So every time we go one place to the right, we multiply by 10 to the minus, if it's one place, minus 1, 2 places, minus 2, 3 places to the right is minus 3. So 0.00571. So we're going to the first number that's non-zero. Okay, so that's the same as 5.71 by 10 to the minus 3. 0.0000621 is the same as 6.21 by 10 to the minus 6. Now, on a calculator, you can just, if you want to convert 2.54 by 10 to the 3, if you want to go from standard form to decimal, you just go 2.54 and you hit the times 10x button to the power of 3 equals 2540. What about adding and subtracting numbers in standard form? So express 1.84 by 10 to the 2 plus 8.7 by 10 to the 3. There's two ways of doing this. You can either go with converting each to their decimal. Okay, so you bounce that twice and you get 184, and you bounce that 3 times and you get 8700, add them up and then rewrite it 8.8 by 10 to the 3. Or you could look to make both these powers the same, either both 2 or both 3. You can make them both 5, you can do it anyway, and add the coefficients. So let's turn 1.84 by 10 to the 2 to the power 10 to the 3, and that's equal to 0.184 by 10 to the 3. So now we can simply write the two numbers over each other, and the two same powers will stay the same, and we'll add these two and we get 8.884 by 10 to the 3, which is the same there. Multiplying and dividing numbers in standard form. So express 3.8 by 10 to the 3 times 9.4 by 10 to the minus 2. Well, there's no worries here. You just multiply the coefficients by each other. You get 35.72 times 10 to the 3 times 10 to the minus 2. And when you're multiplying the multiplication of indices, you add the indices. So 3 minus 2 is 1. So it's 35.72 by 10 to the 1. So just bring it back one place. It's 3.572 by 10 to the 2. And here we have 27 times 10 to the 7 divided by 1.2 by 10 to the 4. So we just divide 27 by 1.2, it gives us 22.5, times 10 to the power of 7, bring this up, minus 4. So it's 22.5 by 10 to the 3 is the same as 2.25 times 10 to the 4. Let's talk about significant figures and approximation. So decimal places, express 6.8537 to 3 decimal places. So what we do is we're looking to write 6.8537 as a number with only 3 digits after the decimal point. So we look at the 4th digit. If it's 0, 1, 2, 3 or 4, we leave that 3rd digit alone. Okay, we'll leave this 3rd digit alone. But if it's if the 4th digit is 5, 6, 7, 8, 9, if this is 5, 6, 7, 8, 9, we'll add 1 to this 3rd digit, which is the case here. So 6.853, look at the 4th digit, it's an add 1 type digit, so this 3 will become a 4, it's 6.854, correct 3 decimal places. Now, what about rewriting numbers to significant figures? Let's look at numbers greater than 1. So express 52764 to 4 significant figures, 3, 2 and 1 significant figure. So the rule is, look at significant figure value plus 1 digit. So if I'm going to convert to 4 significant figures, I look at the 5th digit, 1, 2, 3, 4. I'm going to look at this digit, and if it's one of these, then I'll leave the significant figure digit, the 4th digit, the 6. I'll leave it alone, and I'll make all digits after that zeros. Okay? But if it's 5, 6, 7, 8, 9, 10, if this digit here is one of these, then I'll add 1 to this guy here and make all the digits after zeros. We'll see by example now. 52764 to 4 significant figures. Well, we'll look at the 5th. That's 0, 1, 2, 3 or 4. So that means we will do nothing to this 6, leave it as is, and make the rest zeros. Okay. To 3 significant figures, 5, 2, 7, 6, 4. I'll look at the 1, 2, 3, the 4th digit. That tells me it's in the higher one. I'll add 1 to this and make the rest zeros. Gives me 5 to 800. To 2 significant figures, 5, 2, 7, 6, 4. I look at the 3rd digit. That tells me to add 1 here and make these zeros. So I'll get 53,000. And then 5, 2, 7, 6, 4. To 1 significant figure, I'll look at this. No, this says do nothing to it. So, as in leave this 5, leave this as a 5 and let everything else fall to zeros. Okay? For numbers less than 1 then, the zeros immediately after the decimal point are not necessarily significant. Okay, so what we mean by that is, this 0 doesn't count when we start counting significant figures. So to express 0.07406 to 3 significant figures, then we will look at the 1, 2, 3, the 4th figure, and we'll see that it's a 5, 6, 7 or 8, which means that we will add 1 to the 3rd significant figure and make that a 0, so we get 0.074. To 2 significant figures, then we'll look at 1, 2, and we'll look at the 3rd figure. Bear with me. 0.07406 to 2 significant figures. Then we'll look at the 3rd figure. That's a 0, which means that we do nothing to this and make the rest zeros. We get 0.074 and so on. So express 0.00892 to 2 significant figures. That's the first significant. Second, look at the 3rd. That tells us to do nothing with this. Just leave it as 0.0089. Okay, and just a word about making, when you go to make estimates. Sorry about this now. Okay, if you're making an estimate, with any numbers you're given, round numbers greater than 1 to 1 significant figure, and round any numbers that are less than 1 to 1 decimal place. Finally, we mentioned reciprocals. The reciprocal of a number is 1 over that number. So the reciprocal of 5 is 1 over 5. The reciprocal of 1.8 is 1 over 8. And that's the reciprocal key on your calculator. So to find the reciprocal of 12.8, you said 12.8, hit the x minus 1 key, 0.078. Other keys on your calculation: square root, cubed root, square of any number, and the power of any number. So you can find the eighth, say 4 to the 8, by just simply tapping 4x square 8 equals.